Welcome everyone. My name is Prakash Chipa, and today I am going to present our recent research work ASTrA Adversarial Self-supervised Training with Adaptive Attack. This work is recently accepted in ICLR 2025 Singapore. So the deep neural networks are highly effective, but they are vulnerable to the adversarial examples. A small, carefully crafted perturbations can cause the significant model failures. And traditional attack strategies, including in the self-supervised adversarial training, uses a heuristic fixed attack strategy approach, which fail to understand the model's learning dynamics and also does not establish any correspondence between the training examples and the attack strategy parameters, which makes these attack strategies suboptimal. In order to understand the research problem more concretely, we have done some studies where we have changed the attack strategies dynamically, and as we can see the observations that some of the strategies could result in a better performance in terms of robustness against the baseline ACL methods. Similarly, when we do the ablations with different perturbation strength, some of the results come come to be more robust than before, and this particular observations sets the goal to have a better learning attack strategies for the self AT methods, which can be adaptive and learnable. So taking that motivation to the concrete form, we design a learnable attack strategies using a separate strategy network. These networks operate on the same input, and it aims to learn three different distributions for each attack parameters, iterations, perturbations, and the step size. And interestingly, the learning of this particular network is operates on the loss objectives of the standard target network. So in order to compute the uh, in order to compute the rewards, we update the gradient of this strategy network using reinforce method. So this is the complete proposed framework ASTrA, where besides the standard self-supervised AT settings, we deployed these strategy networks, which provides adaptable perturbations to each examples. And from the loss objectives, we have also introduced a novel loss objectives called mixed contrast, which we can discuss in the next slide. And another important observation is the SSL reward for the strategy networks, which is based on the loss objectives of the target network itself. So the gradient computation is carried out using the reinforcement. And one important observation about the how the network changes its convergence of the adaptive strategy of the networks. So you can see this is for the specific one of the attack parameter. So the initial phase network tends to explore the different values of the parameters, attack parameters, and eventually it converts to some of the specific values based on the model's learning dynamics and based on the dataset images it has. So coming to the mixed contrastive loss, it align the representation of clean view to its corresponding perturbation view, which is based on the adaptive perturbation attack parameters. So this provides a added robustness to the training in a way that it consistently able to align the attacked adversarial view to its clean view. Coming to the results part, our proposed method ASTrA outperform on several benchmarks in self-supervised AT methods across different dataset benchmarks here, and also the detailed results are in the paper where we have done comparison across different evaluation protocols also. And coming to the detailed analysis on the ASTrA about the label efficiencies. So when it compared to the ACL baseline method, ASTrA consistently outperform with improved robustness uh, across the different range of label efficiencies. Similarly, for the robustness overfitting, when training extended to 2000 epochs, ASTRA's robustness shows better, it avoids the overfitting for the robustness and consistently performs better than the baseline ACL. And the modularity part, ASTRA is really works well with as a plug and play module. So that we have shown with another two self-AT methods, ROCL and DynaCL. When it is included with the ASTRA, it improve their performance. So with that, we come to the contributions. So the two major contribution from the is ASTRA framework, where we design and integrate the learnable self-supervised attack strategy, and the second is miscontrastive loss. From the achievement perspective, we have shown the robustness improvement across the datasets and evaluation protocols. Secondly, it is scalable and avoid the robustness overfitting, as we have also shown the results on relatively larger dataset ImageNet 100. And finally, ASTRA not just work with the designated self-AT framework, but also works well with the other self-AT methods and improve the performance. With that, I thank you everyone, and all the people who are visiting ICLR 2025. We welcome you to our poster session also. Thank you so much.